Alright guys, this is section 7.8, Geometric Probability and Odds. Now, just a reminder about probability in general. Probability is going to be a fraction of some sort. It's going to end up being some sort of percentage. Like if you have a test, for example. If you got 14 right, which is the special amount, out of 15, then you would end up with about 93.3% on a quiz or test. Now, today we're going to talk about geometric probability. Geometric probability is a probability that uses a geometric model in which points represent outcomes. For example, if I were to have a dartboard, the bullseye is only a portion of the whole dartboard, and I'm going to find the probability of me being able to throw a dart and hit the bullseye. Okay, first thing, finding the probability using measurements. So when we write this, we're going to write P of the event, so whatever this event may be. And the event is like in this first question where it says, what is the probability of landing between 3 and 7? The event would be between 3 and 7. So we're going to have the length of the special segment divided by the length of the entire segment. Now, the special segment is from 3 to 7, so it's going to be from here to here. And 3 to 7 is the length of 4. And our entire segment is this whole piece, which is going to be 10. So our probability is going to be our special, so our 4, divided by our total, which is 10. And this will reduce to 2 over 5. Now again, this is my special, and this is my total. So my probability is 2/5. That is my chances of landing on a number between 3 and 7. So now we're going to pull this star out, and we're going to find the probability of landing on 4. So if I'm going to land directly on 4, my probability is actually 0 because I don't have any length. I don't have a length. A point is just a point. So I'm going to have my special, which is 0, divided by 10, and 0 over anything is just 0. Now again, the reason that it was 0 is because there was no length. There's no length of a point. There's a length of a line, which is why when we went from 3 to 7, we had a length of 4. But if we have no length at a point, then our length is going to be 0. Alright, so now here's the dartboard. We are going to figure out the dartboard is mounted on a piece of wood. What is the probability of hitting the dartboard and not the wood backing? So we're going to use this formula, which is special area over entire area, or total area. So we're going to need the area of the dartboard. We're also going to need the area of the whole square. Alright, so if we're finding area of the dartboard, we are going to have area of a circle, because our dartboard is a circle. We're going to have area equals pi r squared. Now, if our whole length here is 12, so the distance from one side through the center to the other side is 12, that would be like my diameter length. My radius length is going to be half of that. So my radius is going to be 6, so I'm going to have pi times 6 squared, which is just going to be 36 pi. Now I need the dartboard, or the backing, and we are just going to find the area of a square. And the area of a square is equal to our side squared, which is going to equal 144, because our side is 12. So we have 12 squared, which again is 144, and we need our label, which is centimeters squared. All right, so now we're going to find the probability. So we need our special area divided by our entire area. Our special area is our dartboard, so we have 36 pi centimeters squared. And our total area is going to be our backing, which is 144 centimeters squared. Now, if I reduce 36 pi and 144, 36 divided by 144 is just 1 over 4, and I still have pi, and my centimeters squared are going to cancel. So my probability is going to be pi over 4 of hitting the dartboard and not the wooden backing. Now the last part of this question says, what is the probability of hitting the bullseye part of the dartboard? So we need the area of the dartboard and the area of the bullseye so we have dartboard we already figured out was 36 pi centimeters, 36 pi centimeters squared. Now we're going to find the area of the bullseye. So we have area equals pi r squared, and down here it says the radius of the bullseye is 1 centimeter. So I'm going to have pi times 1 squared, which is just equal to pi. So now we need to find the probability, which is going to be special divided by total. Our special part is the bullseye because we're trying to figure out the probability of hitting the bullseye. So we have pi divided by our total, which is our 36 pi. Both of these are centimeters squared. So our centimeters squared are going to cancel. And then we have pi divided by pi, which is just 1. So our probability is going to be 1 over 36 chances. All right, prepare to be grossed out. Okay, if the roach is stuck inside a box 10 inches by 15 inches in size, what is the probability that it will stop in the red region? And then what is the probability that it will not stop in the red region? So what I'm going to have to do is first I'm going to have to kill my roach. And to kill my roach, I'm just going to smack him. Like that. Ew, gross. There's the grossed out part. So, in order to solve this problem, the first thing we're going to need is our area. Oh my gosh. Okay, I'm really sorry. That example would not work, so we will do that one tomorrow in class. But here's our last example. What is the probability of landing on a green circle? So the first thing I'm going to do is I want you to look at how this is split into pieces. And I end up having 4 circles that are all within squares. So if I'm going to find the area of a square, or the big square, and then the area of all the circles together. The first thing I need to do is find the area of the circle, the first circle. So I have area equals pi r squared. So now, if my whole length here is 16, then that means my diameter of one circle is 8, which means my radius has to be 4. So my area of one circle is pi times 4 squared, which is equal to 16 pi. Now, there's 4 circles, so I'm going to have to multiply this times 4. So I'm going to get 64 pi meters squared for my green circles. Now I'm going to need the area of the square, which is just base times height, which is just 16 times 16, which is equal to 256. So now when we're finding the probability, I have my special area and my special divided by my total. Now I want to land on a green circle. So my special is going to be my 64 pi, and my total is going to be my 256. Now, 64 divided by 256 is 1/4. And then I'm going to still have pi on the top, so I'm going to end up with pi over 4 as my probability of landing on a green square. All right, tomorrow we'll do homework. I'll see you later.